Welcome, this is the Math 8 Chapter 5 Review Packet Solutions. This is going to be broken up into a three series part. This is part 1. We're going to be covering the first 4 problems. Okay, here's the review sheet with the first 4 problems that we are planning to cover. Okay, alright, so let's look at number 1. It says, which system of the linear equations has the solution 2, 1? Alright, notice that we are already given an x value and a y value. The x equals to 2 and the y equals to 1. We get that from the order pair. I color code this to help you see it much better. Next, to check that the solution is valid, we just have to plug it in or substitute. Okay, A, we had four options, A, B, C, and D. I'm going to check A first. So y equals 2/3 x plus 5. This is the first equation. To do this, we simply plug in our values. Y was equal to 1 and x was equal to 2. So I made that substitution. Y was red, it was replaced by 1, and the blue, right, was the x, and that was replaced by 2. Okay, the substitution occur, right? Next, I can simplify. 2 times 2 over 3 is 4 over 3. Because 2 times 2 is 4, then divide that by 3. Notice, I do not even have to simplify this because I already know 4/3 plus 5 is not equal to 1. The number 5 already here shows that it can't be already be equal to 1. Okay? So, we know that this is invalid. So, once we know it's invalid, we move on to the next one. Okay? This was still our x and what our y value was. Now we are going to again check for the solutions. We have to plug it in. Okay, this was the first equation of the second one. Let me show you. Okay, that was my first equation of B. Substitute the values for x and y. The y was the red, which is y equals to 1. The x was the blue, x was equal to 2. The substitution occur, then I simplify. Negative 2 times 2 was negative 4. Okay, 1 equals to negative 4 plus 5. 1 does equal to 1. We say that's valid. Are we done? No. We have to also check for the solution for the second equation. Remember, it is a system of equations. Therefore, it has to be hold true for the first equation and hold true for the second equation. Okay, y equals to 3 over 2x minus 2. Make the substitution in. The y is equal to 1 and the blue of x is equal to 2. Simplify that in. Okay, 3 over 2. Okay, times 2 is 6 over 2. 6 over 2 is still 3. On the right hand side, if you can't see this, just plug into your calculator. 3 minus 2 does equal to 1. So 1 does equal to 1. So it is valid for the second equation as well. The fact that it is valid for the first equation and valid for the second equation, we then say that B would be the correct answer. Okay, so the point 2, 1 is a solution for this system. It's the break-even as well. Okay, next, before doing number 2, okay, number 2 was right here. It says, which of this system equation has an infinite number of solutions? I would like to explain to you what an infinite number of solutions is first. Right. The new idea is how to determine if a system has infinite numbers of solutions. The system is given by that. That is my first equation and this is my second equation. This isn't in the review packet. These are just notes to give you some information. When the two equations are graphed, it looks like this. Notice that the system of equation has infinitely many solutions because they intersect at every point. Notice the first equation and the second equation are right on top of each other. This point is intersecting, this point is intersecting, this point intersecting, this point is intersecting, so on and so on, so on. Every point is intersecting. Therefore, it has an infinitely many solutions because one equation is stacked on top of the other. So the question is, how can you tell if two equations have infinitely many solutions? Okay? Let's see. Here was my problem. I did not do my problem yet. I gave you the two equations from before. Okay, we already know that it should be infinite in this case. Okay, here's my two equations. First of all, step one is to always look for the opposites. Okay, there's no opposite here. The coefficient in front of x, this is 4 and 12, those aren't opposites. 8 and 24, those aren't opposites. So I'm going to do step 1b. I'm going to multiply by something. So the first one, I'm going to multiply by -3. The reason why I'm multiplying by -3 is I make this opposite. -12 and 12. Those are the coefficients or the numbers in front of the variables. Notice -12 is in front of 12. Okay, -24 is the opposite of 24. 108 is the opposite of 108. Uh-oh. Seems weird. Step 1. Okay, because I did the multiplication, I can do step 1 again. Okay, look for opposites. Are there opposites? Yes, I see opposites. So I can move on to step 2. Combine the two equations. Okay, -12 plus 12 is 0. -24 plus 24y is 0. 108 plus 108 is 0. Uh-oh. Notice the equation of 0 is equal to 0 is always true. Hence, because 0 is always equal to 0, hence the system has infinitely many solutions. Right? So the shortcut here, there's actually a shortcut. If you can multiply any equation and the first equation is a complete opposite of the second equation. Do you see how it's 12x? This is a complete opposite. This is also a complete opposite. This is also a complete opposite. They would both cancel each other out, getting you 0, 0. Okay? That is how you can tell that it is infinite. Or they're equal to each other. If you just multiply this by 3, it would be 12x plus 24y equals to 108. Notice if you made the substitution, you see the left hand side is equal to the right hand side. Alright, number 2. Okay, using that idea that we just learned about infinitely many solutions, we can now do this. Okay, remember the shortcut, right? Okay, let's see. So first of all, I'm going to look for the opposites. Okay, I don't see any opposites. 1y is not the same thing as 2y. 2x is not the same thing as 1x. So I'm going to multiply by something. I'm going to multiply this by -2. Notice I rearranged this so the y's are on top of each other and the x's are on top of each other. The reason why I can move them is because of the commutative property, right? 3 plus 5 is the same thing as 5 plus 3. Okay, so that's the reason why I rearranged it. Okay, now we look for the opposites. -2 is the same thing as, is the opposite of +2. So I can move on to my second step. I'm going to combine the two equations. The top equation plus the bottom equation. -2x plus 2x, that becomes 0. -2y plus 2y becomes 0. -6 plus 6 is 0. Uh-oh, notice the equation 0 equals to 0 is always true. Hence, the system has infinitely many solutions. Okay? Therefore, we would say that this C would be the one that is the one that has infinitely many solutions, right? Because notice, I can actually make this equation from this equation, just multiplying this by 2. If you look at A, you can't multiply by anything to make the second equation, right? The first equation, I can't multiply it by 3 to make the second equation. I multiply this by 3, it gets me 6, 6. This actually becomes 27. It's not equal. If I multiply the top one by 2, 2y plus 2x plus 6. Do you see how it is the same, right? Here, I can't multiply anything here to get the second one. Okay? So C would be the only one that would be the infinitely number of solutions. Okay? Think about that. Right? Can you make the second equation based on the first equation? Okay? All right. Let's look at 3 now. Okay? But before we do 3, because 3 says which The following system of equation has no solution. We got to talk about what no solution is. So how to determine if a system has no solution? Here is a picture of no solutions. No solutions are parallel lines. Okay. The system of equations have no solution because they never intersect due to parallel lines. There is no break even. Okay, they do not intersect. The fact that they do not intersect, no break even, that is because they are parallel. They never touch. So here's an example. Okay, these two have the same slope. That's why they're parallel lines. Watch, I graph them. Both of them have a slope of up 3 over 1. Right? Up 3 over 1. Same slope. So, number 3. The following system has no solution. I have this equation. Okay? So, they ask us, the fact that it has no solutions, if you graph them, are there nonlinear lines? Are there perpendicular lines, intersecting lines, or parallel lines? We should already know. When the lines are graphed on the same coordinate plane, they are D, parallel. Okay? Because that is the definition of no solutions. No math is actually needed here. You just need to know the definition of a system of equation with no solution. See the slide before this. Here you go. If they have the same slope, they are parallel. Because they are parallel, they don't intersect, hence no solution. No solution means they're parallel. Good. Let's do number 4. At which point in the coordinate plane do the intersecting defined by y plus 2x equals to negative 4 and y equals negative 2x, y minus 2x equals to negative 4 intersect? Here's my system. First, I'm going to look for the opposites. Ooh, I see an opposite here. Plus 2 and negative 2 in front of the x's. So, notice how I have the value 2 and negative 2. I can combine the two equations. I add them together. Y plus y equals 2y. 2x plus negative 2x becomes 0. Negative 4 plus negative 4 is negative 8. I can move on to step 3. I can solve for the variable. 2y equals to 8 was my equation from the second part, or step 2. Divide by 2 to both sides. I get y equals negative 4. Step 4. Substitute back into the original equation. Y plus 2x equals to negative 4 is my original equation. I substitute y equals to negative 4 back in. I got that from doing part 3. Why do I substitute it back in? Because that's how I can solve for the x, or the other variable. So in this case, I'm going to add 4 to both sides. Why do I do that? Because I'm trying to get rid of the minus 4. So that's why I add 4 to both sides. Here I have the 2. So now 2 in front of the x via multiplication. So I divide by 2 to both sides. 0 over 2 is 0. So in order pair, it would be 0, comma, negative 4. Okay? Good. All right. This would be your coordinate where those two equations intersect. Those are your solutions for questions 1, 2, 3, and 4.